So far in our discussion of operant conditioning, we've only talked about continuous reinforcement. This is when we reinforce every behavior. So after every behavior, there's some stimulus presented. This type of reinforcement results in fast learning, but it also is susceptible to fast extinction. When we stop providing the reinforcer or the stimulus, the learner can easily detect that reinforcement has stopped, and so that reinforced behavior will extinguish quickly. But in everyday life, we see more cases of partial reinforcement, and this is when behaviors are intermittently reinforced. This reduces the extinction of a learned association. It can also save resources. We don't have to give out food rewards for each behavior, for example. So when we look at partial reinforcement, we can look at different scheduling of reinforcement. And the schedules can vary in two ways. First, they can vary in the basis for providing reinforcement. We can reinforce on schedules of instances or trials, or we can reinforce based on time. For example, a factory worker could get paid for a certain number of parts they make, or could get paid for a certain number of hours they work. And the other way that the schedules can differ is based on the regularity of the gaps in reinforcement. So we could have regularly spaced reinforcers that happen, or we could have variably spaced reinforcers. So with the example of the factory worker, they could get paid every hour, so this is a regular schedule, or they could get paid every so often, so sometimes after an hour, sometimes after 3 hours, and this would be a variable schedule. So if we draw this out as a chart, we have ratio as one type of scheduling, and this is when we reinforce after a certain number of behaviors, and we can have interval scheduling, which is when we reinforce after some amount of time. And if we look at what the spacing is, we can have fixed spacing, so this is with predictable and constant spacing, or we can have variable spacing, and this is with unpredictable and varied spacing. So we'll start in this quadrant where we have a fixed ratio schedule, and I'll draw out what this looks like. So here on the x-axis, we're looking at the passage of time, and on the y-axis, we're looking at the cumulative responses. So we'll indicate our reinforcement events with this purple tick. And here we see with a fixed ratio schedule, we provide reinforcement after a constant number of behaviors. So after 5 behaviors, for example, we reinforce. Then there's a short pause after the reinforcement, and then we see rapid response continue. So the more you do, the more you get. So with this schedule type, we see reinforcement after a specific number of behaviors. So one example would be a frequent buyer punch card at a pizza place. If you buy 10 slices, you get the 11th one free. This is an example of a fixed ratio reinforcement schedule. This type of scheduling results in high response rates, but it demonstrates a relatively lower resistance to extinction. The learner knows when to expect the reinforcement, so if the reinforcement doesn't happen, extinction will occur more quickly. In this quadrant, we have a variable ratio schedule, and we can draw this out. So again, we've got time on our x-axis, and we've got our cumulative response on our y-axis. So here we see these reinforcements are presented with variable spacing, and this reinforcement occurs after an unpredictable number of behaviors. But the reinforcement is provided based on the behaviors and not time. So you actually have to complete a task in order to have the possibility of receiving the reinforcer. So one example of this is a slot machine, where every time you pull the lever on the slot machine, you may or may not win. This results in high response rates and also high resistance to extinction. Every time you play, you don't know which time you'll win, but you know eventually you'll win. In this quadrant, we've got fixed interval schedules. This is when the unit of scheduling is time, and we're looking at fixed spacing of our reinforcers. So here we've got time again and cumulative responses on our y-axis, and we see a reinforcement that occurs after a certain amount of time has passed. And in this case, it's a fixed amount of time. So after the reinforcer is presented, we see a stagnation in response. So one example would be students that study for a scheduled exam. You work very hard just before the exam, but you can slack off after. So this results in something called scalloping. This is when we see a stagnation in the response immediately following the reinforcement. And this type of fixed interval schedule results in lower response rates and is also not very resistant to extinction. If we don't provide that reinforcer, the person knows that it's coming. If we all of a sudden didn't give a test that was anticipated, this would lead to an extinction. And then finally, we have a variable interval schedule. And this is when we have reinforcement after irregular periods of time. So we see our responses accumulating and irregular spacing between our reinforcers. Now, if we shorten the intervals, we'll see a higher rate of response overall. In this scenario, the learner can't predict when reinforcement occurs, though they know that it will happen eventually over time. Receiving a text message would be an example of a variable interval reinforcer. You don't know when you will get a text message, but it'll come at some unpredictable time. Or a pop quiz in a class might come at some unpredictable time. You know it'll come, but you don't know when, and this might reinforce good study habits. So with this variable interval schedule, we see low but steady response rates, and we also see high resistance to extinction. So we see this line that continues upwards with the accumulating responses. So here are some scenarios to practice with. For each one, go through and identify what the schedule of reinforcement is that's happening. So go ahead and pause the video now, and I'll share the responses after the pause. Pause now. All right, we're going to unpause. So here are the answers for these scenarios.